All right. Pause the video at any time to capture these notes. 1, 2, 3, and 4. All that information will be helpful for your model lab, and just kind of like an order of operations for how you go from the straight chain to the cyclic form. But also that model lab kind of represents what happens in real life as well. So the models do a good job of representing that. It's important to note that the formation of a cyclic structure or a ring will form an additional stereocenter, an additional asymmetric carbon, which allows two different stereoisomeric or enantiomeric forms to exist. So what are we talking about here? Carbon 1 in the aldehyde starts off with 2 bonds to oxygen, which means that it is not a stereocenter because it has 2 of the same things, whereas carbons 2, 3, 4, and 5 are definitely stereocenters. When that chemistry happens and the ether forms in the furanose, what happens is that carbon at position number 1 is no longer bonded in an aldehyde. It is bonded to a hydroxyl group. A hydroxyl group that could be pointed up in the beta form or down in the alpha form. And that's what we call an anomeric carbon. So the carbon that started off not as a chiral carbon, but became chiral when the chemistry took place. And so let's see here. So an added additional chiral carbon emerges. So because of that, we get these 2 different stereoisomers, the alpha and the beta form. Not sure I explained that all that well, but hopefully you got the gist of that. So page number 2, part 4. Again, go back and pause that as needed. So it is important to recognize that we are talking about in aqueous solution. We are talking about in solution that very little of the glucose will be in the straight chain form, about 1%. About 65% will be in the beta D-glucopyranose form, and about 34% will be in the alpha D-glucose form. And that is because of steric repulsion. So this gets back to Vesper or valence shell electron pair repulsion theory. Remember, there's a lot of lone pairs of oxygens, lone pairs of electrons around these oxygens. And those lone pairs of electrons are negatively charged. Those negative charges will repel one another. So when you build these structures as model kits, you'll see that these hydroxyl groups in the alpha form are in closer proximity to one another, where then the hydroxyl groups in the beta form, because they're like literally on opposite sides of the ring. So there are less steric repulsions between those lone pairs of electrons. So here, this is kind of a higher energy configuration. And the beta form is a lower energy configuration. Because it is lower in energy, it is more stable, and so it would predominate about 65% of the time. 34% of the time be in the alpha D-glucopyranose form, and then the rest of it would be made up in the straight chain form. Now we need to talk about Haworth projections. So we have the Fisher projection, which you should know from last class in the quiz that you just took. And then we have the shorthand version. Remember, the triangle represents the carbonyl, and the circle represents the CH2OH. And numbering carbons is going to be really, really important for figuring out what the cyclic structure will look like and drawing the cyclic structures or the Haworth projections properly. So let's see here. One thing to note is that if the Fisher projection is a D form, then this will be what we call flag up right here. If it is an L form, it will literally be drawn in a way that looks like an L right there. And that then you use carbons 2, 3, and 4 to figure out whether your OHs are going to be up or down. If they're drawn to the right, like carbons 2, 4, and 5, then they will be down, up, down. So this is carbon 1 right here. This is carbon 2 right here. So you have down, up, down. And then the beta form will be the hydroxyl group on carbon 1 will be pointed up for beta and down for alpha. And if you want to represent it as neither alpha nor beta, you just draw that bond as like a squiggly line right there. So that designates neither alpha nor beta. I'm going to stop the video here and then get to the next one.